This lesson is on naming ionic compounds. We're going to talk about three types of ionic compounds in this lesson. The first type, we'll call this type 1, are ionic compounds with monovalent or one charge ions. For the most part, these cations are from the representative elements families, groups 1A, 2A, and 3A. When you're naming this type of ionic compound, you always give the full name of the metal. The metal atom and the metal ion are the same. So give the full name of the metal. And remember, metals always come first in your ionic formulas. When you're naming your anion, you give the root name of the anion, which is always a nonmetal, and then you change the ending to IDE. So fluorine would change to fluoride. Chlorine would change to chloride. These compounds will end in the ending IDE. Let's look at a few examples. First off, notice that these all begin with a metal. Sodium's a 1A metal, lithium's a 1A metal, barium is a 2A metal, aluminum is in group 3A, again sodium is from group 1A, and calcium is from group 2A. So you have a monovalent metal, and they end in an anion, a nonmetal. These are binary compounds containing only two types of elements. So chlorine, oxygen, nitrogen, and fluorine are all nonmetals. So let's name these. Full name of the metal: sodium. Chlorine changes to chloride, CHLORIDE. Lithium, and then oxygen changes to oxide, OXIDE. The third one, barium, BARIUM, full name of the metal, and then chlorine changes again to chloride, CHLORIDE. The subscripts do not affect how you name these compounds. Always give the full name of the metal and then the root name plus "ide" for the nonmetal. Now pause the video and you try the next three on your own, and once you have named them, resume the video and see how you did. I'm going to go ahead and complete these. Aluminum, oxide, sodium, nitride, and calcium, fluoride. How'd you do? Hopefully you got them all right. If not, please edit your papers. Those are type 1, containing a monovalent metal and a nonmetal. Now what about if you have an ionic compound that contains a multivalent ion? Now remember, those are mainly your transition metals that are multivalent. Of course, tin and lead also are included there. When we name these type of ionic compounds, we use a system called the Stock system. That means you use Roman numerals. I will abbreviate Roman numerals RN. We use Roman numerals after the metal name, and the Roman numeral represents the charge on the metal cation. It gives it the specific charge, so there's no question as to what charge was used in the formula. Now remember, we only use a Roman numeral if the cation is multivalent. We do not have any multivalent anions to worry about, so it's only going to be used if the metal ion is multivalent. So that means when you have a transition metal or tin and lead. Remember, the two transition metals that do not need a Roman numeral are zinc and silver because they are monovalent. So you will never need to use a Roman numeral with zinc or silver. All right, so for the most part, you name these the same. The only difference is that you're going to give a Roman numeral to specify the charge that was used on the metal. I'm going to go ahead and name these. Name the first element iron. Now iron is going to need a Roman numeral, so I'm going to go ahead and put a parenthesis here for the Roman numeral, a holding spot. We'll come back to that in a second. But you still continue to name the second part the same way. Iodine changes to iodide. I-O-D-I-D-E. Root name plus "ide," still. So what we have to do now, because iron is a transition metal, it has more than one charge, we have to figure out the charge iron used in this formula. Now this is going to sound a little counterproductive or counterintuitive, but this is what you have to do, because remember, with ionic formulas, sometimes they're reduced. So the subscript that it looks like was charged, it was crisscrossed, was not always the charge that got crisscrossed. So you have to be very careful. So what that means is you really want to start with your nonmetal. So look at your periodic table and check out iodine and refer to the charge it should always cross, because iodine's charge is always going to be the same. Remember, iodine is a halogen. That means when you label your charge for iodine, you would have labeled it a -1. So when you crisscrossed it, you would have crossed a 1 down here. And when you look in this formula, that's exactly what it is a 1. So what that means is whatever charge iron crossed is what we see here. So this 3 got crossed down from the iron. So that means iron crossed the 3 down. So we're going to name this iron Roman numeral 3 iodide. Now, as opposed to if it had have been iron 2, because that's the other charge iron could have crossed, if it was iron 2, the formula would have been like this. Label your charges, +2 - 1, and when you crisscross, the 1 would come down and a 2 would come down. So in that case, the formula would have been FeI2. Notice there's a difference. So that's what we have to name them to give the specific charge that was used. The Roman numeral has to show, or will show, the charge from the multivalent metal. Let's look at number 2. Nickel is also a transition metal, so that means this compound is going to need a Roman numeral in the name. But we still name the full name of the metal, nickel. I'm going to go ahead and put my parentheses for my Roman numeral. We'll come back to that. And then this is phosphorus. So that changes, phosphorus changes to phosphide, P-H-O-S-P-H-I-D-E. Now let's figure out the charge on phosphorus. In this, on nickel. And to do that, you're going to start with the phosphorus. So look at your periodic table, and you will notice that he's in group 5A, which means he would have crossed a -3 charge down. So when you look, that's exactly what he crossed. So that means whatever nickel crossed is down here. So a 2 is what we see. That means nickel crossed a +2 charge down when the formula was written. So since nickel is using a +2 charge, when you name it, you're going to say nickel, Roman numeral 2, phosphide. Let's look at number 3. Again, copper is multivalent because he's a transition metal, so this is going to have a Roman numeral, but we still name the full name of the metal, copper. I'm going to put my parentheses where a Roman numeral is going to go in a second. And then fluorine changes to fluoride, F-L-U-O-R-I-D-E. All of these end in "ide," so keep that in mind too. Let's decide what charge copper used in this formula. Start with the fluorine. Fluorine's a halogen. That means he always has a -1 charge. So when you look down, you see that he did in fact cross a 1 down. That means that copper also crossed a 1 down. So we are going to say copper, Roman numeral 1, fluoride. Now, here's 5 for you to practice on your own. Please pause the video You try these 5 and then come back and check your answers with mine. I'm going to go ahead and complete these now. All of these contain multivalent metals, transition metals. Iron's a transition metal, copper's a transition metal, chromium's a transition metal. Now we're going to go ahead, and I'm just going to suggest for now, go ahead and name the first element, full name of the first element, put your parentheses, root name plus "ide" for the second element, and then come back and figure out the charge. So I'm going to go ahead and do that for this. Iron, parentheses for my Roman numeral in just a second, and chlorine changes to chloride. So let's uncrisscross this formula. Chlorine's always a -1, so I'm going to check it and see. Yep, he crossed a 1 down. That means that iron crosses 2 down, so that means that this should be iron, Roman numeral 2, chloride. All right, number 2, copper. We're going to need a parentheses, so I'm going to get that ready for the Roman numeral, but I'm going to go ahead and say root name plus "ide" for the sulfur, so sulfur changes to sulfide. All right, let's figure out the charge the copper crossed. Now remember, you want to always start with your nonmetal because their charge is 100% guaranteed, the pattern we learned on the periodic table. So sulfur is a chalcogen. He's in group 6A, which means he's always going to have a -2 charge. And if you look here, that's exactly what he crossed. That means that copper crossed the 1 that's understood there. So this is going to have a +1. So we're going to call it copper Roman numeral 1 sulfide. Number 3, chromium. Full name of the metal. Fluorine changes to fluoride, Fluoride. And now let's figure out what charge chromium crossed. So start with fluorine. He's a -1 always because he's a halogen. Yep, that's what he crossed. So that means that chromium crossed a +3 down. So we're going to call this chromium Roman numeral 3 fluoride. All right, let's look at number 4, copper. So name him copper. Put your parentheses because we're going to come back and put the Roman numeral in just a second. But this is ending in oxygen, so oxygen changes to oxide, Oxide. Now let's figure out what charge copper crossed in this formula. Remember, start with oxygen. Oxygen is a chalcogen, group 6A, and they always cross a -2 down. Okay. Now this is the first one that we've seen like this. These can be tricky. You've got to always watch out for reduced formulas, and this one is a reduced formula because we know oxygen always crosses a 2, but we don't see a 2 right now. So what does that mean happened? It means that it was a 2. It had to get reduced. That means it got divided by 2 and became a 1. So that means whatever copper crossed also got divided by 2 and it became a 1. So what that means is copper crossed a 2 down, +2. This is actually copper Roman numeral 2 oxide. Now, if it had been copper 1, the formula would have looked like this. Cu and O, copper would have been +1, oxygen would have been a -2 because he's always a -2. It would have crossed the 2 there, that would have crossed a 1 there, and so the formula would have been Cu2O. That would be copper 1 oxide. So be very careful, look out for reduced formulas. All right, let's take a look at number 5. Chromium. We're going to need a Roman numeral. Put a Roman numeral, and then nitrogen changes to nitride, Nitride. Now let's figure out what charge chromium crossed here. But remember, you got to start with the nitrogen. So look on your periodic table. You see he's in group 5A. That means he crossed a -3 charge. But look, there's a 1 there, y'all. That means this is also a reduced formula. We know he always crosses a 3, but it got reduced to a 1. That means it got divided by 3. So whatever chromium crossed also got divided by 3, and it became a 1. That means chromium crossed a +3 charge down. This is chromium Roman numeral 3 nitride. How'd you do on those? They're a little harder, I know, a little more difficult. You got to think about them a little bit more. But just uncrisscross the charges, use what you've learned about the charge patterns, and you'll be okay. The third and final type of ionic compound, I call them type 3s, are those that contain polyatomic ions. They're called polyatomic ionic compounds or tertiary ionic compounds. Now, the thing about these is if you learn the polyatomic ion formulas and names, you're good to go, but you got to memorize them. You got to refer to them. Remember, most of your polyatomics are easily recognizable from their names because they end in ATE or they end in ITE versus IDE, which is what all the compounds we've named up until now ended in. Most of your polyatomics end in ate or ite. There's only a few exceptions to that. Ammonium is an exception, hydroxide is an exception, and cyanide is an exception. But for the most part, these end in ate or ite. I want you to notice these formulas. Look at what they have that's different. These are not binary. They have more than two types of atoms. So this has sodium, phosphorus, and oxygen, calcium, nitrogen, and oxygen, nitrogen, hydrogen, phosphorus, and oxygen. They contain polyatomic ions. Something else you notice here about these formulas is that they have parentheses, many of them do. Not always, but these all have parentheses. So that's another way you can kind of pick out a polyatomic ion. All right, so let's name these. Sodium, you always give the full name of the metal. Now sodium does not need a Roman numeral because he's in group 1A. He's monovalent. So you don't have to worry about a Roman numeral here because sodium does not need a Roman numeral. Now we got to name this guy. This is a polyatomic ion. It has a name. The name is phosphate. Now you may have to refer to your polyatomic ion list in the beginning to name these, but you do need to focus on memorizing their formulas and memorizing their names. For the 22 that I gave you, they're the most common ones. So number 1 is just sodium phosphate. Number 2, calcium. Calcium does not need a Roman numeral because he's in group 2A and he is monovalent. This is NO3 with a -1 charge. That was nitrate, Nitrate. And here we have ammonium. Remember, he's your only polyatomic cation. All the other polyatomics are anions. And then this is just phosphate. So we just call it that, ammonium, AMMONIUM, phosphate, PHOSPHATE. Notice all of these end in ate, ate, ate. Sometimes they'll end in ite. All right, so let's practice all 3 types for our final little bit of this lesson. All right, we're going to name the first element, sodium. Then you want to ask yourself, does sodium need a Roman numeral? No, he does not because he's monovalent. He's in group 1A. Move to your second one. That's just nitrogen. So since it's not polyatomic, we're going to do root name plus ide. So nitride. Sodium nitride is the name of that compound. Number 2, SRS, strontium. Strontium does not need a Roman numeral. He's in group 2A and he is monovalent. So you move on to the next element, sulfide, IDE, root name plus ide. Number 3, Fe is iron. Iron does need a Roman numeral. Again, you might need to refer to your periodic table till you really learn which ones are mono and which ones are multivalent, but iron's a transition metal, so he's going to need a Roman numeral. And then we're going to say bromide. So let's figure out the Roman numeral that iron crossed. Well, bromine always crosses a -1, and that's what he crossed here, which means iron crossed that 2 down. So you should say iron, Roman numeral 2, bromide. Number 4, zinc. Now, zinc is a transition metal. However, remember aluminum, zinc, silver, +3 + 2 + 1. Zinc does not need a Roman numeral because he's monovalent. So you keep on moving on and you name oxygen oxide. Root name plus ide for the second element. Number 5, you got 2 polyatomic ions here, ammonium, phosphates, ATE. Notice it ends in ATE, the others ended in IDE. Okay, that's it for our lesson on naming ionic compounds. We'll pick up with the next type of compound in our next lesson.